Thanks, Ellen. Good evening, everybody. Just while I wait for Ellen to get my slides up, hope you're all keeping safe, and hope we can see each other again face to face in the not too distant future. So I'd like to really start by talking about what I consider quality silage. Next slide. Next. So if we're thinking about quality silage, we need to have a target. That's the most important. But we also need to measure and assess against that target. And it's crucial, and it's something that some farmers are very good at and some are not so good at, is being self-critical. Really assess what you have done in your silage making, the whole process, to see whether you've hit your target. Next slide. So here are my targets, and they're different for different categories of livestock. So this is the energy target, the ME target, and for high producing animals, that's milking cows, finishing beef, pregnant ewes, we need at least 11 ME, and I'd prefer it if it was 11.5 ME. Whereas on the other extreme, we've got the dry cow, be that a suckler cow or a dairy cow, and there the maximum is 10 ME. And in the middle, we've got growing cattle. Next slide. So I would prefer the growing cattle to actually be moving towards the minimum target there for milking cow. If we now look at the crude protein, again, we have those three groups of stock. Same groupings. High producing animal, we should be aiming for 16 to 17% crude protein in our grass silages, whereas with the dry cow, we should be down at 12 as a maximum. And again, with the growing cattle, we should be nearer to that high producing animal than we are with the suckler cow and the dry cow. Next slide. Now, I've got two targets for our percent dry matter, and that depends whether it's clamp silage or bale silage. And for clamp, I'd say you should be aiming between 28 and 32% dry matter on most farms. With the bale silage, that can be drier, 35 to 45% dry matter, but often I see bale silage too dry, and there's very few arguments for that, and hopefully after the end of today's presentation, you'll see why I'm saying that should be your target. Next slide, please. So we really need to focus our value on grass. And here I have the 5-year analyses from Farming Connect of the three different crops there. There's approximately 1,000 samples in here, the majority are grass. And I've got the green bar is the maximum within those 5-year analyses, the blue bar is the minimum, and the mean is in the red. And we can see with the grass, we're almost hitting that 10.5 ME target for energy. With whole crop on the mean, we're about 9.5, and you can see that there's better and worse. And on the maize, one thing about maize is it is consistent. If you can grow it, it is a consistent energy content there. But if we just refocus back on the grass, we can see that we've got a huge range there. The best being just over 12 ME and the worst down at 8. Now, what is behind these figures is that we don't know is whether those silages were destined for dry cows or for pregnant ewes and milking cows. But it just shows that huge range, but it also shows the potential from our grass that we could get if we focus attention. Next slide, please. Now we have the crude protein, and again with the grass you can see that huge range, the mean hovering around 13%, the best there up at 21%, 22%. I'm hoping that in those silages we had some legumes, red clover, and a high concentration or a high proportion of red clover. But again, like I said, the mean is around that 13%. With the whole crop, the mean's a little bit lower than the grass, but the maximum is much lower. And we will never get a high quality silage from whole crop. It's not designed for that sort of, you'll never get there. The higher protein there is probably due to some undersown legume within that whole crop. And then when we look at maize, obviously that's not really a protein crop, so not really relevant in the protein story. But again, I'm just showing there the range that we've got within the Farming Connect analyses. Next slide. Now I've split the dry matter ones between clamp and bale, so the next slide will be bale, but on this slide we've got the clamp silages, and we can see there the percent dry matter year on year, and the mean is actually pretty close to that target I said, 30 to 30 or 28 to 32. The mean is always in there, but we've got some very wet ones. Obviously that's a bigger challenge with some of the summers we have and some of the weathers when we're making it, but I would say those drier ones are well above where we should be for clamp silage, and I'll come back to that, the reasons why in a minute. Next slide, please. Now with the bale silage, again, our means, sorry, back one, please. With the bale silage, we're actually, again, within that target, but with the top end of that target dry matter, just above that 45%. But again, you can see some very dry bale silage there, and again, some very wet bale silage. And it just shows that, you know, if we focus attention, we can hit those targets year on year. Next slide, please. So quality, there's two aspects to quality. There's the quality at cutting, and if we want high quality, we need to cut early. If we want stemmy material for our dry cows, then we need to cut when it's in full seed head. And then the other aspect of quality, which is often overlooked, are the losses between cutting and feeding. So for the next few minutes, I'm going to spend quite a bit of time looking at those losses. But first of all, we'll just focus a couple of slides on quality at cutting. Next slide, please. So if we consider how grass changes between nice leafy material there on the left-hand side, 78D, ME 12.5, through to full seed formation in that grass crop at 58D, ME 9.3. And the main factors changing are the fiber fractions are increasing with that increasing maturity. Sugars are going up, but our protein, our oils, and our mineral content are dropping. And that fiber fraction, the NDF there, is increasing as that stem elongates. And the main negative of that is actually the lignin at the bottom. And whilst it's only a small proportion of that total grass, it actually binds to the cellulose and the hemicellulose, making it less easy for the animal to digest it and degrade it in the rumen. Next slide, please. So this is an old quote. You can see 1951, and it's stating what I would be stating today. We cannot emphasize too strongly the importance of cutting herbage young for silage if we want high production from that silage in our high producing animals. And the consequence on the next slide of cutting late is that, okay, we get a yield increase. That's just on that first cut. But our digestibility and our metabolizable energy are dropping. We have higher field losses because we've got a bigger bulk there. It's taking longer to wilt. So we're losing more of that crop in the field before it actually gets into the silo, whether that's a clamp or a bale. And there's a slower regrowth. And actually, as the crop matures, the tillering point on the grass increases in height. So when we come and cut it, we're cutting out more of those tillering points when we're doing a later cut with a lower digestibility. And there's a greater risk of aerobic spoilage at feed out. So they are all three negatives. So the only positive on this slide is that yield increase, but it is just for that first cut. Next slide, please. So this is what we see when we have a mature crop. You'll see a dead sward base, and again. And within that dead sward base, what we've got is lower feed value because we've reduced the digestibility of the fiber, and we've got lower protein. You can see it's dead and dying. And if we could look closely, we would be able to see on that grass mold. And that mold and the yeasts there that aren't visible actually stay in the silage, clamp or the bale, and increase the risks of aerobic spoilage. Next. In addition, for the sheep farmer in particular, when we have that increased dead material in the bottom, we have an increased risk of listeria, and we have an increased risk of mycotoxins. Now, this is a slide just showing an early cut versus a conventional cut over a two-cut system. So we hear a lot these days about multi-cuts, but you know, a two-cut system is what happens on many farms in Wales. And we can see that the early cut system, we have first and second cut, 11.8 ME, 11.4 ME. Yield on that first cut on the early cut was 4.2. Yield on the conventional cut, first cut was 5.5. So there's that yield difference in that cut. But when we look at the second cut, we can see that the early cutting system, much higher yield than the conventional cutting system on that second cut. So if we look at the total yield, we can see we have an actual yield increase where we do that earlier cutting system. And if we just look at the potential milk yield per hectare there, or per cut, that's 18,519 versus on the conventional cut, 17,173. Now, one of the negatives that farmers keep telling me is that they have an increased contractor cost because they're cutting earlier, they've got lower yield. But actually, when you put in a standard contracting cost and cost that out per pence of litre of milk produced, it's still worthwhile doing that earlier cutting system in terms of the cost benefit basis. Next slide. Another way of looking at this is if you've got 1,000 tonnes fresh rate of silage, it's at 30% dry matter, that's 300 tonnes of dry matter. If we increase our ME content from 10.5 to 11.5 ME in that 300 tonnes of dry matter, that's equivalent to 300,000 megajoules extra energy. And if we use those standard figures, that's 60,000 litres of milk or 7.5 tonnes of beef from that better quality. Now we can argue with those figures, but it's just showing the benefit to you if you need high production silage to actually be cutting earlier before there's a stem in the grass whilst it's still all leaf. Next slide, please. So now I'm going to look at dry matter losses, and there are two aspects to dry matter losses. There's the visible, which often we see, and then there's the invisible, and we never see those. Next. So the visible is often there, but seldom evaluated. The invisible is always there, but never evaluated. And I want to take you through now some of the issues this invisible losses cause. Next slide, please. Now, those invisible losses are mainly carbon dioxide and water. There are some other, like acetic acid will volatilize from the front of your clamp, and that is an energy loss. But the main ones I'm focusing on are carbon dioxide and water. Next slide, please. So when we consider these losses, they are three different things. The first one is respiration in the field. Sugar going to carbon dioxide and water. The plant is still actively, still a biological system. It's still respiring when it's being cut. We also have the possibility of poor fermentation, and I've just given one example here, but the sugar is then converted to less efficient acids, the acetic acid, carbon dioxide and water. And if we get heating during feed out, we get aerobic spoilage, and that's sugar and lactic acid being utilized to CO2 and water. But we don't see this CO2 and water, it just vanishes, and so we don't think we've got these invisible losses. Next slide, please. So if I just focus on these invisible losses, if on the left-hand side pie chart there, we've got no losses, that's in the field immediately pre-cutting, and we've got 75% digestibility in our grass. That means we've got 25% undigestible material. Now, if we have 5% invisible losses, we only lose that from the digestible part. So our digestibility is now 70%, and we've got 30% undigestible. Now, many farms will have as much as 10% invisible losses. So our 75D silage, or grass, is now 65D silage, with 35% undigestible material. Now, this has a double whammy effect, because every mouthful your animals eat, they've got less nutrition. But because there's more indigestible material there, that fills the rumen up more, so they actually have less forage intake, because it doesn't pass out so quickly. So they don't feel hungry, so they don't eat so much. So there's less nutrients in every mouthful, and they consume less mouthfuls. Double whammy in terms of your production from silage. Next slide, please. So if we look at dry matter losses, we've got the visible there on the left-hand side, and I see this all too often where trailers are overfilled grass doesn't end up in the trailer, it ends up blowing around the field. But there on the right hand side, we've got the invisible losses. And this plant here is respiring. So if we now look at the next slide, we can see that that's respiration. You have to believe me on that. But if we go to the next slide, we can see what happens when we wilt our grass. So this was a farm near Aberystwyth, wilted, 3 fields, and we sampled those fields at those time points there in the circles. Now I said this was going into a clamp. I said my ideal dry matter was somewhere between 28 and 30. And you can see we hit that after about 15 hours. But this farmer picked it up after about 26 hours. Now, what happened to the sugar during that time? Next slide, please. At mowing, immediately after cutting, there was 22.9% sugar in that grass. When it had been through the forage harvester and was tipped out at the clamp, it was down at 18.7% sugar. And that sugar had disappeared to carbon dioxide and water, shown there on the red part of that graph. But you wouldn't see that. Next slide. If we then compare the D value in the field, it was around 74.2, 11.9 ME. At forage harvesting, it had dropped to 11.2 ME. So we'd lost that energy. Now we'll always lose some energy because we always have some respiration during wilting. But we need to optimize that wilting period so that we can get it down, so that we can reduce those losses and improve our silage quality. Next slide, please. Now, if I take that example just a little bit further, and I put in a hypothetical yield of 5.5 tonnes of dry matter per hectare, then with that loss at forage harvesting, that's 5.25 tonnes. If we work through those figures, and you can go back over the presentation again, but I just want to focus on the ME content. That was a 5.7% loss. And if we converted that into a milk yield, it's a 10.2% loss in milk, or 1,250 litres different per hectare because of those losses. Now, like I said, we'll always have some, but if we could save half of that, I'm sure 600 odd litres in the tank per hectare because you wilted more rapidly is well worth thinking about. Next slide, please. So just a quick resume of what we need to do when we're mowing and wilting. We should have a minimum cutting height of 5 centimetres, but with open swards, new reseeds and legumes, that should be raised up to 7.5 to 10 centimetres. And the stubble actually acts as an airbed, allowing airflow underneath and increases the speed of wilting, so reduces our losses. And actually by leaving that stubble in the field, all we're leaving is the less digestible part of that grass. We should always use mower conditioner, and we should ted as quickly after mowing as possible. Rapid wilt, maximum of 24 hours, but as short as possible to reach that target of 28 to 32% dry matter. Next slide, please. So everything I've said so far is relevant to you, whether you're making clamp or bale. I'm going to present a few slides each on clamp and bale separately. Compaction is absolute key. So to know whether you've got good compaction, you can see here on that top picture, you can see the tracks of the wheels still in the grass. I go on many farms and that's bounced back up because it's not being compacted well enough. Next slide. Compaction is so important because it governs the density. So here, this is a survey of around 35 farms in America, and they've got the density there on the left-hand side, 160 kilograms per meter cubed, up to 320 kilograms of dry matter per meter cubed. And on the right-hand side are the percent dry matter losses over an 180-day ensowing period. So we can see with the lower density, we have 20% losses. So that's the equivalent of 1 load in every 5 that came into the silage clamp. Whereas at the high density, it was only 1 load in 10 that was lost. So improve density, reduce our losses. Next slide, please. 2 reasons why we get these losses. Initially, we trap oxygen. The grass is still respiring, so we're producing that carbon dioxide and water again. but no acid, so we're not controlling the process of ensiling. We also have the enterobacteria. These are everywhere, and often on your grass in your field there will be 1 million of these bacteria in every gram of forage, and they can grow aerobically and anaerobically. So if we've got air there, they grow very well. They'll be doing the same respiration as that top part, but when it becomes anaerobic, they're again producing carbon dioxide and water, utilizing that sugar inefficiently, increasing the losses. Next slide, please. So how do you maintain high density during silage lamp filling? And there's no tool you can use at filling to measure the density as you go. But this is a quick calculation. So I've got there a fairly standard twin axle trailer, 2.7 meters wide, 4.7 meters long, 2.4 meters high, giving it a volume of 30.5. Your ideal clamp filling layer depth is 15 centimeters. That way we get even consolidation and we can get good consolidation. So now we need to calculate how far we need to push that 30.5 meters cubed of forage if we're filling layer depths of 15 centimeters. And I've put in here a loading shovel width of 3.1 meters. So in that example, each and every load needs to be spread over around 67 meters in length. And that's important with the first load, the second load, all the way through to the last load. Otherwise, we have an uneven compaction and we have an increased risk of clamp slippage. Next slide, please. The other thing, and this was part of an AHDB survey of English farms that I conducted 3 years ago now, is know your dimensions of your silage clamp, particularly the width and the height. So the average of these 20 farms was 2.5 meters high and 12.8 meters wide. Next, that gives us a volume, an ability to look at how much of the silage is within half a meter of the wall or half a meter of the top sheet. And all too often, I go on a farm and I say, oh, you've got some waste there on the top. And they say, oh, that's just a bit on the top. Well, if you do this calculation, you can work out how much of your silage clamp is within half a meter of the wall and half a meter of the top. And the average in this study, next, was 26% of the volume of the silage. And the way we can preserve that better is by good sheeting and good covering after we've sheeted. Next slide, please. Now, this is one of the clamps I visited, much wider than that average. And next, if we look at the top of this clamp, it's got a significant amount of top waste. And that top waste has higher ash content. So go to the next slide. So I'm going to give you an example now of what that top waste has meant. And I've pulled together data from 2 different farms. So this was the first farm where there was good consolidation that I showed earlier. And then we have next and next. So we have an ash content in the grass at harvest of 7.9% in that particular example. And then in the middle of the silage clamp there, good feed out, good solid wall, next. We can see that had an ash content of 8.2%. So we've had a little bit of loss there because ash is a measure of losses as well as soil contamination and minerals. Whereas in that top waste, we had 19.1% ash. And we can use this relative ash measurement to calculate how many dry matter losses we've had. So next. So during that calculation, you can see in the center of that clamp, good consolidation, 4.3% dry matter losses. In that top region, and if we knew how much silage was there, we can see the 78% losses. So you might see a thin layer, but if you could do this calculation, and if we'd weighed every piece of that top waste from that farm, we'd have had to add a 78% increase in the weight that we got off that to actually calculate the true losses. So sheeting up it properly is absolutely essential to maintain that quality. Next slide, please. Also want to talk about temperature and density again. That key measure of density is related to the temperature at feed out. So this is a clamp just over the border in Shropshire, measured at 9 different points. So top left, all the way down the left-hand side, top, middle and bottom. Same in the center, top, middle and bottom, same on the right-hand side. And you can see there, the top left had a density of 230. My target on a fresh matter basis would be somewhere around 750. And we can see the density measurements. Then we can measure the temperature on the surface at feed out, 20 centimetre depth or 50 centimetre depth. And the surface, which is what a thermal imaging camera will do, they look all very similar, around 13 to 16 degrees C. Whereas at 20 centimetre depth in that top one, it was 48 degrees C, a huge amount of heating. If we look in the middle there, centre middle, sample 5, it was actually quite cool at 20 degrees C, but then going further down, top right, we had another increase in heat of 33 degrees C. That heat is energy lost from your silage. Next slide. And if we just think about it, this is how we define a calorie. 1 calorie is the heat it takes to heat a kilogram of water by 1 degree C. And 1 kilocalorie is 4.18 kilojoules. So just as an example, in the top left sample of that previous slide, it took 19 megajoules to heat 1 meter cubed of silage. And that's assuming the process of that heat by those yeast and molds that cause the heat is 100% efficient. And that was driven by the poor density in that silage. So that's 16 megajoules in that 1 meter cube that you haven't got to feed your animals because the density wasn't adequate. Next slide, please. Right, now to bales. Now, we've talked about dry matter losses. The average in a clamp is around 25% across the UK. The absolute best you can get is 10%. Bale, the average loss is 10% and the absolute best around 1 to 2%. So when people tell you bales are expensive, you need to factor in your dry matter losses. They're more expensive to make, but you may end up with more forage to feed to your livestock if your dry matter losses are lower. And everything I said about clamp, density and sealing are absolutely spot on for your bales. Next slide. So, compaction, density. Chopper bales are wonderful at improving the density in your bales. The other thing they do is means you use less polythene because you're actually getting more silage in each bale. So you have immediate cost saving from that increased cost it may cost you to make that chop bale in terms of fuel use. Wrapping. With a bale, we're wrapping it much more quickly. We do ideally need 6 layers of wrap, and we should really wrap at the stacking site. So long as that's done within a couple of hours, that's absolutely fine. As soon as you move that wrap bale, you run the risk of damaging that wrap and increasing air and increasing the problems of dry matter losses and mold formation. And the new film on film technique, instead of the net around the bale, is much better than the traditional method. Film on film, there's increasing data showing an improvement. And then at stacking, we must adjust for percentage dry matter. So if we've got drier bales, 3 high is fine. But if we've got wetter bales down at 20%, 25% dry matter, then 1 or 2 high is absolute maximum because we stretch that film and we increase the risk of damaging that due to the bales going out of shape. Next slide, please. Now, I haven't talked about silage additives. I haven't really had time, but I want you to remember they're the icing on the cake. If you do everything right, you much better benefit in terms of cost of that additive and the benefits you'll see from it. It's not something that will cover up management mistakes. There is a lot of information thrown at farmers and about additives, and it's a problem for the industry, but it would require a long presentation to actually get all that information to you so that you could make a reasoned choice on which additive to use. Next slide. So, in summary, dry matter losses in clamps cost around £25 for every tonne of dry matter on the average UK farm. They reduce silage intake and quality. We have field losses. We need to wilt rapidly, like I said, following those procedures. And it is worth having a look to see whether the trailers are being overfilled and whether you're losing some forage that way. At the clamp, consolidation is key, sheeting and top weight. also essential, making sure no air can get in there, and the same with bales. Wrap them well and make sure you don't damage that wrap, and then feed out rapidly using well-maintained feed out equipment, and you will reduce those losses and you will have higher quality and more production from your grass silage. Next slide. Thank you. And just a word about questions. Today you're all anonymous, so please feel free to ask whatever question you like, whether it is related to the presentation or not. Thank you.
Brilliant. Yeah, thank you, Dave, for your top tips on silage quality. So yeah, as Dave mentioned, I'd now like to open the floor, as they say, for some questions. Type any questions you have on the box on the bottom of your screen, the Q&A section. I can see that some of you have already been posting some questions during the presentation, so I'll just start with them. I think you mentioned at the beginning that it's important to set targets for silage quality. So what would you recommend in terms of creating silage that targets different nutritional needs?
So one of the biggest problems I see on suckler beef sheep farms is that those farms try to make one type of quality. And I'm convinced this is costing that farm a lot of money. Now, it's easy to say that we only want to make silage once, but for your dry suckler cows, you need stemmy, full seed head material. But for those pregnant ewes and for the growing beef and the finishing beef, you need much higher quality. And so I would be saying that a 5-week regrowth or a 5-week from closing the field gate to harvest would be ideal for those high quality silages, whereas an 8 to 9 week would be ideal for the suckler cows and the dry cows. So I think we really do need to focus attention on that. And there's many benefits from making those two types of silage. Okay, you may only have one clamp, but think about which one you're making the most of, make the other one in bales. The other benefits are the health of the animal. So particularly with the sheep, there's evidence coming out now that prolapses are reduced when we have that higher quality because of that faster flow through from the rumen, and we have a much lower risk of molds, mycotoxins and listeria when we make that higher quality. So I really think it's worth addressing that situation in terms of your silage making and seeing whether you can fit that into your system. And don't forget, if you take an earlier cut, that grass will then grow quicker. You can either take a second cut or you can start grazing it quicker. So there's lots of positives in there. And when I say early cut, what I mean is the time from when you shut the gate. I know a lot of sheep farmers, they don't have a first cut, not like the dairy farmer does, because they're not making silage in May, but it's that time between closing the gate and cutting that's important, not the time of year.
Brilliant, thank you. So just another one, can you make quality silage or haylage from an old ley?
It's an interesting question. It depends on the quality of the old ley. So if you've got a lot of weed species in there, a lot of weed grasses, then your digestibility is never going to be as good as one of the new ryegrasses on the current list. If you've looked after that ley and you've got a lot of ryegrass in there, it won't be so bad. And if you've got a lot of clover in there, it can actually be very good. So it really depends on the quality of how you've looked after that ley and how much of the dominant grasses are of the high nutritive type of grasses.
Yeah, brilliant. And just another question on bales. So are O2 barrier bale films worth the cost?
As far as I'm aware, there's no trial work. Personally, I would say the best thing you can do is stack at the stacking site, drop those bales onto some very soft material and move them minimally to the stack. I think when you're looking at the costs of the O2 barrier film for bales, personally, there's a lot of farms that do a damn good job with bales, that don't need an O2 barrier to make it mold-free and high quality. So I think attention to detail there would solve you the cost of buying an O2 barrier. And that O2 barrier is no more resistant to damage than your standard films.
Yeah. So another question, can you get grass sampled at mowing to assess which fields need reseeding urgently?
You can, but that wouldn't necessarily tell you whether that field needed reseeding urgently, because it might have been that you hadn't had enough fertilizer. The most important thing is assessing yield. So assessing yield on each field is very important, and new technologies are coming in that will help you. There are a lot of trailers now fitted with weigh bars, so you can actually properly monitor yield. The John Deere self-propelled has a yield monitor on it, which in the trial work I've been involved is looking pretty accurate. And now even some of the new balers are having weigh cells on the balers, because there's big bale to bale variation within a field, but they are also monitoring bale weights. So I think the most important thing you could monitor is actually yield, which would then drive your decisions on whether a field needs reseeding. In terms of quality, there's so many things that will determine that quality. One is time of cutting, 2 is fertilizer management, 3 is how good your soils are, which is part of the story over and above what type of grasses you've got there. But everything there should be monitored, yes.
Brilliant. So just a quick question on forage wagons. Is compaction in the clamp an issue in comparison with a precision chop forage harvester, given the reduction in field losses from overfilled trailers and hourly rate for lower yielding cuts? Is a forage wagon coming back in fashion, or?
I'd like to be looking into the person's eyes that asked that question, because it depends on the way you use the forage wagon. So a lot of forage wagons are not used correctly. The knives aren't sharp enough. Now with the new mow wagons, they're self-sharpening, they should be sharpened at least twice a day. You must move the crop in the field so that your pickup, so that you spread it and then you row it up again. And some farms aren't doing that, they're rowing 3 rows into one, and then the forage is coming straight between the knives. Now, if you manage that crop right with a forage wagon, your chop length should be down to 2.5–3 centimeters, the vast majority of it. And if you can do that and you shake it out right when you're putting it in the clamp, you will get good consolidation. Unfortunately, on many farms I go on that have used a forage wagon, they've not got good consolidation, which means their losses in the silage clamp are greater than a precision chop. And so they've lost the benefits of not overfilled trailers and not blowing away in the wind, because their silage quality has lost that energy. And then they have problems with intake. And there is work now going on in a harper about chop length and intake, and long chop will reduce intake. But if it's managed well, it's wonderful. If it's managed poorly, it can be a disaster.
Yeah, brilliant. So just a quick question, how soon can you safely open a clamp of grass silage to feed?
It's always safe to feed, because that fermentation, the fermentation happens very quickly, but you could open I know farms that don't actually seal the clamp. Some of the big dairy farms that are feeding silage all year round, they don't have time to seal the clamp. It's bad news for the clamp. It's not bad news for the cow or the sheep, because the clamp needs time to stabilize so that you don't get, or you reduce the risk of aerobic spoilage. So the big risk of opening early is increased risk of heating at feed out, because the fermentation hasn't happened to preserve or to kill off the yeast and molds that cause that aerobic spoilage. So that's your biggest risk. I would always recommend leaving a clamp sheeted for a minimum of 6 weeks if possible. But if you're up against it, I would prefer you sealed your clamp for 6 weeks or 2 months, and actually made some bale silage that if you needed to feed immediately.
Brilliant. And I think earlier on you mentioned closing off the fields earlier on. How long would you normally wait until the silage is ready to be cut then?
So if I want silage for cows, milking cows, finishing beef, sheep, I'd say 5 weeks. If you're really keen, you could go in at the end of the 4th week. But if it's for dry cows, then I'd be looking at 8 weeks. So it depends what the stock are you're feeding.
Yeah, brilliant. And I've just got, we already mentioned, you mentioned old leys, but what are your thoughts on silage from diverse grass or herbal leys?
There's quite a lot of interest in them. There's quite a bit of work going on them at research institutes. I think they have some challenges because within that herbal ley, you've got a mix of species, some of which like to go to flower very quickly, particularly in dry spells. It's something that I think we're learning about. In terms of fermentation and ensiling, they will all ensile okay. My concern is that you'll have areas of rich in one particular herb in a field because of the ground conditions, the weather conditions in that particular spot, and then somewhere else you'll have a different herbal ley in effect, and you're introducing variability to the animal. Now, if that's a beef animal or a sheep, it's not so bad, but if it's part of a precision milking cow ration and you're getting big variations, that can really upset the ration in terms of your protein and energy and your dry matter. So I think they are a challenge, but I think some of the benefits, given that we are seeing increasingly variations in weather over the growing period, they are more resilient. So we could, with time and knowledge, actually improve our yields in these changing environmental times in terms of weather and climatic conditions.
Yeah, brilliant. So I think, thank you all for sending the questions through. I think we've got some time for a few more as well. So at the beginning, you mentioned the importance of, getting the silage tested just to see what the nutrient values are. Are the standard analysis accurate for red clover silage, or should we be wet analysing the silage then?
So in terms of the NIR analysis, there are problems even for grass with certain analytes. So for grass, your protein, your ME, your digestibility, your NDF are quite good. The fermentation parameters, lactic's not too bad, but the VFAs, acetic, ammonia, and sugar are very poor on British analyses by wet NIR. When we come to the case of clover, about 3 years ago now, they introduced a load of clovers into the NIR calibration, but I'm not convinced we have it right because there is a huge variation. When a farmer says he's got clover in his silage, that could be 5%, it could be 70% clover. So what I recommend is that for clover-rich silages, so anything over 20-25%, a protein analysis by wet chemistry, and possibly also an NDF. And then if you're taking nutritional advice, a good nutritionist should be able to work out from those two wet chemistry analytes the quality of that silage relative to the grass silage that you have. So fine doing NIR because it's relatively cheap on that clover-rich silage, but those two parameters are so important that it's worth doing wet chemistry, and that will cost you £30–35 for a sample for both protein and NDF.
Yeah, brilliant. And then just again, in terms of mowing or when to cut, should you be basing your decision on height of sward, or should you be basing it on the number of weeks the field's been shut out?
Sorry, Alan, I missed the first part.
Sorry, how would you base your decision to cut the grass? Is it based on grass height, or should you be basing your decision on the number of weeks shut out?
Definitely neither. You should be basing it on the stage of maturity of the grass. So if you want high quality silage, then there should be a minimum amount of seed stem, not seed head, but seed stem. And that should be there, that should be around 75D. If there's very little stem, mainly leaf, 75D. If you want something that's more mature for your dry cows, then you should have full seed stem and, well, relatively mature seed head. So it's about stage of growth. It's not about time, because each year, particularly over the last 5-6 years, time since you shut the gate isn't a great way of doing it. And neither is yield, to be honest, because we need to be looking at this grass more as how many litres of milk or how many kilos of beef, rather than how much grass silage are we going to make. That's the important thing, because that's what's making you money. So it's all about that stage of growth.
Yeah, brilliant. And earlier on, you mentioned as well, possibly the benefits of having 2 cuts. But what about like the multi-cut system, where you see about 5 cuts? Do you think that they're cost effective?
I do. I think the multi-cut for a farm that's using a lot of silage, particularly in the dairy world, a multi-cut system works very well. And we need to start valuing that grass silage. So if we've got a multi-cut, we can increase the ME from our grass silage. We can actually, if we get a high ME silage from all of those cuts, we're decreasing the variability between cuts. And that means that we're getting more consistent ration through the silage feeding period, which means that we get less fluctuations in milk yield. It means that we're getting more consistent nutrition, because the balance of the ration can be better every day. So we're producing more from our silage. In addition, because we're putting much more nutrients, because it's more digestible, we can reduce our concentrate input. And one of the issues some nutritionists have is they'll say there's not enough fiber, but they forget, because it's highly nutritious, your cows can eat more, so their fiber intake can be greater because they're eating more silage, less concentrates, and you have far fewer production diseases when you're putting more silage in the ration, less concentrate. And all those costs are actually in your hands, so you can actually be more profitable, or at least manage those costs better if you've got those costs, because you've got that high quality silage at your fingertips.
Yeah, brilliant. And just a few more before we finish then. We've had a couple of questions on red clover, specifically when to cut and how long to wait for wilt. Okay,
so there's a requirement for clover in the autumn to flower, so that you get enough nutrients into the soil for it to survive the winter. But all other times, and that's the same for lucerne, all other times you should really be looking at it when it's in early bud, not flower, but early bud, to get the high quality. There was a second part of the question, wasn't there?
So how long to wait for it to wilt?
Right, wilting, yeah. Clover wilts more slowly. You still shouldn't go over that 30 to 32% dry matter target, because you get leaf shatter. And that means that you leave the leaf, when it gets too dry, breaks and stays in the field. So you lose all the benefits of the protein. I'm happy for a 48-hour wilt, but like I said before, if you can get it drier quicker, you'll have better quality. So if we've got a typical sward, mixed sward grass clover, your first cut's likely to be 30% clover, 70% grass, and your second, third cuts are going to be more 70 clover, 30 grass. So that first cut, I'd be looking at a shorter wilt because there's less clover in there. But a 48-hour wilt is fine with clover. The other thing I would say with clover, you should really add a homofermentative inoculant with 1 million bacteria as a minimum, because it is a more difficult crop to ensile because of our high protein.
Yeah, brilliant. And just a couple more. So for pit silage, especially with shorter wilt time, would you straw on the bottom of the pit to soak the effluent, capturing the energy to feed something, or would you recommend that?
I wouldn't. I think with this, the problem with putting straw in is that you will end up feeding that straw, and that straw will reduce the quality of your ration. So ideally, we should be targeting to get to that 28% dry matter. And if you're, most of the time we should be able to do that if we increase the cutting height to that 5 to 10 centimeters in wet weather, and that we spread it in dull overcast weather. If we get caught out, then I think you're just going to have to take a hit on the effluent, or you can buy adsorbents. And if you want to, you can put in very sugar beet pellets, but they need to be small. That will absorb it, and it'll give you much better feed value than putting straw in, or even rolled cereal, dry rolled cereal. It's a better approach than straw, because as soon as you put the straw in, you end up feeding that straw and you end up reducing the intake.
Brilliant, fab. I know that we've got a few questions left, but I think we might have to wrap it up, as I'm just quite conscious of time. But hopefully